Now let's try PyTorch, which is equally powerful for AI and ML. Here is a similar classification model in PyTorch. Generating sample data. First, we import libraries, torch and torch.nn for PyTorch's neural network tools, NumPy for math, and make classification from scikit-learn to create fake data. The make classification function creates 1000 data points with two features, both useful for classification, any formative equal to, and to class number class equal to, like healthy or unhealthy. The random state equal 42 ensures consistent results. We set number redundant equals 0 and number repeated equals 0 to keep things simple. Then we convert the data to PyTorch tensors with a torch.tensor. The labels x are reshaped to column, reshape -1 and 1 to match our modulus output. This data is like a spreadsheet of crop measurements ready for the neural network to learn from. Think of X as a table of crop measurements and Y as a list of healthy or unhealthy levels. The dot coda is like sending this table to a super fast computer in the cloud in the neural network. Here we create a neural network using PyTorch's nn.Module. Think of the network as a decision-making machine with layers, like a brain with neurons. We define a model class with two layers. Layer 1, a linear layer, nn.linear 2,16 takes two input features, for example, NDVI and soil moisture, and connects to 16 hidden neurons learning patterns. ReLU, an activation function, nn.ReLU, adds non-linearity, helping the model learn complex patterns by turning negative values to 0. Layer 2, another linear layer, nn.linear 16,1, reduces the 16 neurons to 1 output. Sigmoid, the sigmoid function nn.sigmoid squashes the output to a value between 0 and 1, which is perfect for predicting healthy 1 or unhealthy 0. The forward method tells the data how to follow through these layers from input to layer 1, then ReLU, then layer 2, then sigmoid. This structure is like a mini brain learning to classify crops. The neural network is like a chef mixing ingredients into steps. First, blending them into 16 flavors, hidden layers, then deciding if the dish is good or bad, which is output. Now we create the model with the model.coda, moving it to the GPU for faster training. The optimizer uses the Adam algorithm, torch.optim.adam, to adjust the model's weights, like tweaking a recipe to improve the taste. We pass model.parameters to tell it what to optimize. The loss Fn equal nn.BCE loss, which measures how wrong the model's predictions are for our binary classification task. It compares the model's output 0 to 1 to the true labels, giving a score to minimize. These three models, optimizer and loss, are the core of training our neural network. Training the model. Here's where the magic happens, training the model. We loop 10 times, range equal 10, over the data, called epochs. Each epoch does this. Output equal model X feeds the data through the network to predict probabilities 0 to 1. Loss equal loss Fn outputs, comma Y calculates how wrong the predictions are using binary cross-entropy loss. Optimizer.0 grade clears all calculations to start fresh. Loss backward figures out how to adjust weights to reduce the loss. Optimizer.step updates the weights to improve the model, and print shows the loss for each epoch, which should decrease as the model learns. Run this in Colab, and you'll see the loss drop, like from 0.4 to 0.1, as the model gets better at classifying the data. Training is like teaching a student to solve a puzzle. Each epoch, they guess, check their mistakes, which is loss, and adjust their approach to get better. Evaluating the model. Finally, we evaluate the model with a torch.no grade. Disables gradient calculations to save memory. We run the data through the model X, predict classes. If output greater than 0.5, predict 1, else 0. And compare to true rules X. The mean calculates the accuracy like 0.92, meaning 92% of predictions are correct. This tells us how will our model learn to classify crops, for example. Evaluation is like grading a test. We check how many answers the model got right, giving us a score like 92%. So, this code trains a neural network to classify data, like predicting crop health, using PyTorch in Colab's GPU environment. You'll use similar techniques in coming modules. Try the coding exercise to tweak this code and share your results in the Q&A forum. Let's keep building your AI skills. Now, we run the PyTorch script. The accuracy with the 10 epoch is 4.50. Let's change this 10 to 100 epoch and run it again. Just in seconds it runs. And the accuracy from 0.5 increased to 0.87. Tips for success. You have just trained TensorFlow and PyTorch models in the cloud. Great job. Here are tips to succeed. Always use GPU and TPU for faster training. If you need a refresher, you can visit our previous lecture. Second, experiment with the parameters, like adding layers or changing epochs to see how they affect accuracy. Next, save notebooks to Google Drive. File, choose Save to keep your work safe. And share outputs in the Q&A forum. I'd love to see your results.